proportion, and probability. So just a little summary or overview of this chapter. The first part of it is all ratios and proportions. So we're going to be talking about our ratios, different ways to write them, what a ratio means, how to simplify them. Probability, which is about the last 2 or 3 sections of the chapter. We'll get into a lot of probability. This is a part of your book where I supplement a lot. I take some worksheets from algebra books that I've had, and I'll make it a little bit harder. Still the same concepts and skills that are in your book, though. Okay, so this chapter, little different than everything else we've done so far this year. All of your skills from solving equations, simplifying fractions, long division will definitely be needed in this chapter. Please keep in mind that your book, every chapter before the one that we get to, always builds on the next topic. Okay, so you're always going to need all those skills and concepts that we've already learned this year. After this chapter, you will have your next cumulative exam, just to keep that in mind, and obviously that'll be on your next semester grade. That'll be a long test, so I'll probably give you guys like a period and a half to work on that, since it'll be on 6 chapters. Okay, so that'll be after chapter 6. There is a quiz in this chapter, so you'll have a quiz in this chapter and a chapter test. Chapter 5, there was not a quiz, you just had a chapter test. Okay, in case you guys like to plan in advance. Okay, 6.1, the objective is to find ratios and unit rates. Does anyone know, in your own words, what is a unit rate? Anyone know? Joseph, what's a unit rate? Good, so $3.99 per gallon. Right? Or maybe you used 10 gallons of water for every shower you take, right? A unit rate, your denominator is always 1. However, a unit rate is still a ratio. So we're going to talk about both of those topics today. Okay, let's start with going through the warm-up answers. I just want to go through the answers with you guys and girls first, and then any questions we'll come back to. Steve, you okay? Staple remover? That's fine. That's fine. All right, number 1, Ray, what did you get for number 1 on the warm-up? Number 1, not number 2A. You didn't do number 1. Okay, tell us what you got for 2A then. Good job. Okay, so there's 2A. Nathan M., let's go back to you. Go to you for number 1. Good. $9.95 per balloon. Okay. Oh, well, is that right? Oh, 2 O's would help, right? Thank you. Thanks, Gia. Did you spell wrong too? Not just me. All right, 2B. Kevin. Great job. Alexis, 2C. Wait, say that again. No, not 2.6. This one's a little tricky. Greta? Good job. You got -14 on this one. I'll come back to it if you guys need me to. Okay, let's go to 3A. Grace, what did you simplify 3A to? Good. Jackie, 3B. Didn't get to that one? Amberly? Good, 1/2. Shane, 3C. You got to keep simplifying. 21 goes into each of those. Or that. Good, 2/3. Greta, you were going to say that? Okay. All right. Any questions or anything you need me to go back to on the warm-up? Josh? Kevin? Yes, I can. Who else needs 2C so I know who needs it? All right, I'm going to move this. You guys all right if I move this? All right, 2C. Kevin, I'll kind of ask you, since you asked about it, kind of what you did first. So we have 7/8 B plus 7 less than -21/4. Okay, what is the very first thing that you did? Okay, I wouldn't do that. Here's what I would do. If you're doing that, well, did you change it to a decimal? Okay. I would change this first to have a common denominator. So change your 7 to 28/4. Okay? and then move that to the other side. Maybe that's where you messed up? Skylar, what did you do? Okay. Okay, I gotcha. So Kevin, did you kind of do the same thing? You changed this to -5 1/4 and then subtracted 7 from the mixed number? Is that what you did? And you just left it as a mixed number? Okay. All right. Skylar, did you get the right answer? Okay. Camille? I'm going back to you, Kevin. That's fine. That's fine. You can do that as well. And there's a lot of ways to do this. Raise your hand if you guys changed all of these to have a common denominator of 8. Who else did that? Okay. Okay, so a couple of you did. All right, let's keep doing it this way. Now, guys, remember, there's a lot of different ways to do this, so check your way. Alexis, did you do it this way? Okay. All right, well, let me keep going here. Next step, subtract 28/4 from both sides. Okay, so we have here 7/8, was it B? B less than -49/4. Okay, you with me? Okay. And again, guys, this is one way to do it. Next thing, how we typically do it in class is then multiply both sides by 8. So I'm going to multiply both sides by 8. This goes away. Okay. I'm going to cross simplify here. 4 divided by 4 is 1. 8 divided by 4 is 2. And then multiply across the top, across the bottom. We're left with 7b less than -2 times -49 times 2 is -98. And then divide both sides by 7. You get b is less than -14. Alexis, you okay? Okay. You did not fail. Anyone else, anything about this question? Gio, head up, please. Okay, anything else on the warm-up? Abigail, sorry, I didn't see you. A? 2A? Okay. Okay, 2A. Right. All right, 2A, we have 1/12K plus 1/3 equals 5/6. So, Abigail, what is the first thing that you did so I can kind of do it the way? Okay. Okay, and then you move 2/6 to the other side by subtracting, right? Okay, well, that's why. But anyway, your next step, just in case, you have 1/12K equals 3/6, and then from there, multiply both sides by 12, cross simplify, and you end up getting 6. Steve. What did I do? It's a K. It's just my messy writing. Thanks, though. Anyone else on this one? I can keep going if you need me to. Okay, anything else on the warm-up? Okay, let's start with some definitions here in your notes. Okay, first definition is ratio. Here's definition from your book. Ratio uses division to compare two quantities. So we talked about this a little bit. Miles per gallon, water per minute. There's a lot of things you can think of in regards to comparing two quantities. Okay, you can even think of this in regards to your grades of classes. So a ratio is always going to use division to compare two quantities. And we're going to go through a lot of examples today, so you'll see a bunch more. Okay, second definition, equivalent ratios. You guys know from chapters 2 and 3 that equivalent means equal. So equivalent ratio are ratios that have the exact same value. We're comparing two quantities, but when you simplify them, they are equal. They are comparing two quantities, and they're equal. The definition for proportion, I need you to kind of cross off. We will get to that in the next lesson. So just kind of cross that off. We will get to that in the next lesson. Okay, when you're ready, go ahead and flip over to the next page. There's a box at the top that says writing ratios. Okay, this is in the Algebra 1 book, so you'll actually see this again next year. So here's what it says. You can write a ratio of two quantities, A and B, where, of course, the denominator, which is B, is not 0, and you can write it 3 different ways. So there's three different ways to compare two quantities. In other words, there's three different ways to write a ratio. One of them is A to B. Another one is A colon B. And the last one is A divided by B, kind of like just writing a fraction. You need to make sure that you're reading the ratios as the ratio of A to B. You should also make sure that your ratio is always completely simplified. That's why Chapter 5 is before this one. Neil? Okay, I'll come back to them in a little bit. Let everyone finish this first. Did you not start when we started? Okay. So you want to make sure that each ratio is written in simplest form. After you write that, I would circle simplest form. That way you have that. And then each ratio is read A to B. 1 to 2. 1 to 4. What'd you say, Nathan? Yes, there you go. Neil, remind me at the when I'm done with the notes, I'll give you my packet, okay? Okay, is it okay if I move, guys? Okay, next part. We have an example now, and I'm going to kind of read through this example. Our job is to write the ratio that they ask us to write, okay? So it says an archer shoots 60 arrows at a target, with 44 arrows hitting the scoring area and 16 missing the scoring area. So 44 arrows hit it, 16 miss it. How can we evaluate the performance? We need to write the ratio in three ways. So let's first start with letter A. Asks us to compare two quantities, which are the number of hits to the number of misses. So I'm first going to write it as a fraction. I have a bad habit of always writing it as a fraction first. You don't have to agree with me. You could write it with the word 2 in between first or with the colon. Okay? So we're comparing hits to misses. What numbers are we filling in for hits and misses? Abigail? Close? Good. 44 and 16. So there's our fraction. 44 over 16. Before we write this two other ways, what did I tell you on the last slide that you always need to do with a ratio? Skylar? Good. Simplify it. Who can remind us on their calculator, how do you simplify a fraction on your calculator? Just to save you some time. Steve? Good. After you type in on your calculator 44 divided by 16, hit math, enter, enter, and it reduces it for you. So what is the simplified fraction for hits to misses? Amberly? Good. 11/4. We need to write this two different ways. What's one other way to compare hits to misses? Abigail? Good job. Have the colon, and what's the other way? Right? Good. 11 to 4. So 11 hits to 4 misses. Steve? Okay. So make sure it's simplified completely, and if they ask you, which I probably will on a quiz, write it 3 different ways, just so you always remember there's 3 different ways to write a ratio. Also remember, a ratio is always comparing two quantities. Okay? Okay, letter B. The number of hits to the number of shots. Go ahead and see Ms. Wingrove, please. Okay, on this one, we are comparing hits and shots. Okay, so the two things we're comparing here are hits and shots. What numbers are we plugging in for hits, but then total shots? Jackie? Good. 44 over 60. So now it's how many times you actually hit it over how many times did you actually shoot it. So your total is going to be on the bottom. Make sure you're reading carefully when they ask you to transfer something or translate something to a ratio. Okay, we need to completely simplify that. Shane, what is the simplified fraction? Good, 11 over 15. Michelle, what's one other way that we can write this? Say that again. Over. Say it, I just didn't hear you. Good job. Colon 15. Sorry, the fan is loud and they're loud in the hallway. I can't hear standing over here. Mike, what's the other way we can write a ratio? Good. 11 to 15. So make sure it's completely simplified. Here are our 3 ways to write it. Questions on that one? Okay, let's go to example 2. Okay, example 2 is kind of open-ended, so here's why. They asked us to write, and we're not going to write all of them, but they asked us to write all ratios, both in words and with values, that can be made using that figure. So we need to solve and check each equation, show our work. We are not going to write all of them, but I want to get some of them from you guys. Take a look at the figure that's here. What are 2 things, there's a bunch we can compare, but what are 2 things that we can compare just by looking at this figure? Nathan S.? Checkered to blank. Okay, so I'm going to say checkered to white. So we can compare the checkered rectangles, we could call them, to the white rectangles. Okay, someone besides Nathan S., what numbers can we fill in if we're doing checkered to white? Drew. Okay, why did you change your mind? Good job. There are 6 checkered ones, 1, 2, 3, 4, 5, 6, or you can call them diamond ones, I don't know. And then there are 4 white ones, 1, 2, 3, 4. So just make sure that what you're referring to translates to the number that you're writing there. Peyton? Now, if we were to change it, it would be a different ratio. So no, it doesn't matter, but for now, we're going to kind of stick together since we're kind of doing these together. But no, if I ask you a question, Peyton, and say, find the ratio of checker to white, it has to be 6 to 4. If I were to ask you, find the ratio of white to checkered, then it would have to be 4 to 6. Does that make sense? Okay. Josh, completely simplified? Good, 3/2. Kevin, what's another way to write 3/2 as a ratio? And Alexis, what's the last way? Good, 3/2. Okay, let's do one more. What's something else that we can compare just by looking at this figure? So what are 2 other quantities that we can use? Camille? Good. So let's do checkered to total. Okay, Neil, what number are we filling in for the checkered and what number are we filling in for the total? Good job. So there's 6 checkered, there are 10 total rectangles in that figure. And then Grace, completely simplified, 6/10 reduces to? Good, 3/5. Peyton, what's another way to write 3 divided by 5 as a ratio? Good, 3:5. And then Nathan M., what's the last way? Good, 3 to 5. Okay, questions on the checkered white rectangle problem? We're just doing 2 of them. There are many more we can do, but I'm sure you get the point. Okay, flip over. Okay, don't drop your notes. Flip over. Okay, I want you guys and girls to try just example 3. Okay, so example 3 asks us, okay, it says the ratio comparing the length of a bird's wings to the average width of the bird's aspect ratio. Order the birds in the table from the greatest aspect ratio to the least. The first thing I want you to do is find the ratio of each of them, okay, and then see if you can put them in order. There's a couple ways that we can do this. Think back to chapter 5, which we just finished. I would say using decimals is probably the easiest on this, okay, or you can just kind of use mental math, use common sense, figure out which one's the largest, which one's in the middle, which one's the smallest. I'll give you a couple minutes. Okay, you want to use the aspect ratio, which they tell you is the wing length to the average wing width. Guys, all right? Okay, go ahead and see what you can come up with, and we'll go over that in a couple minutes. Yep, yep. Oh, how'd you get that? There you go. Just write it wrong. Okay. You can do it like that. That's a good way to do it. And then put them in order from least to great, or sorry, from greatest to least. So largest would be the first one. The biggest one is the first one. Yeah, but you want to put them in order from biggest to smallest. So number them. You know what I mean? Yep. Yep. Anyone else have a question? You okay? Okay, and you guys can use whatever strategy that you prefer, and we're going to talk about that in a couple minutes. Good job. Okay. Good. Good. Just hang out for a minute here. Ray, I need you. Oh, you did finish them. Good. Awesome. Good job. Did you finish? Okay, just make sure. Oh, you did number them. Good job. Oh, actually, look at that again. 2 of those need switched. Good job. Good job, Josh. Oh, did you put them in order? No, you just set them up. Okay, what I would do is either find the decimal or mixed number of each of them and then put them in order from largest to smallest. Okay? You okay? Sure? Okay, just change your mind. You know what you're doing? Okay. Okay, good. Okay. Nathan M., what did you put for your aspect ratio for the white-tailed eagle? So what is your ratio of the wing length to the average wing width for the white-tailed eagle? 209 to 30. Now, how did you simplify that? Did you change that to anything? Okay. What decimal is 209 over 30? Peyton? Good. 6.96 repeating. What else could we have converted that to? Jackie? Good. You also could have converted that to a mixed number, and there's one other thing we could have done that we'll talk about in a second. Amberly, what is your ratio for the European J? 47. Good. What decimal is that? Okay. Did you change it to mixed numbers? No? Did you find common denominators? Okay. Abigail, what decimal is that? Good job. And in the black-headed gull, go ahead, Gio. Okay, just tell me what is the ratio, the aspect ratio for the black. Good job. Okay, and then I'll ask you what you did in a second. Who can tell us what the decimal is? Abigail? Good, 10.375. Okay, so here's our decimals. Now let's also talk about, besides converting into decimals, yes, we could have done mixed numbers. That's just as easy. What else could we have done? Gio, what was your strategy or method?
Well, mine was to round the numbers on the left to the nearest one that the one on the right could go into, and the number that was the biggest to go first.
Great. That's a great strategy. Did you guys hear what Gio said? He rounded this number to the nearest whole number that 30 would go into. So he did that for all these so that when he divided them, it came out as an integer instead of a decimal. So that's a nice way. I didn't think about that one right now. What else could we have done? Or what else could you have done? Ray? Yeah, mental math. You could have used common denominators and just compared the numerator. That was probably pretty easy as well. Most of you guys had this when I came around. The black-headed gull was the largest. The white-tailed eagle was in the middle. And then European Jay was the smallest. Okay? Ray?
What if it's like so that it goes into 83 and 10 times, but if you do 30 times 10, that would be 120, 12 times 10,
Good. I like that way as well. Good way of using your mental math skills. Good. Anyone else? Questions or comments on that? Okay. Let's skip to example 5, please. Okay, we're going to do 2 of these, so don't go too far ahead of me. Example 5 is an example of the ratio is already given to us. We just have to rewrite it and simplify it. So you do not have to write this 3 different ways. We're just writing each quotient as a ratio and then simplifying. Okay, so really we just need to simplify here because a fraction is a ratio. Mike Banco, 4 yards over 16 inches. What can we simplify that to? Good. So 1 yard. Now this is one where you need to keep the units with it. 1 yard to 4 inches. Now you may write it as a ratio with the word 2 in between it, or with the colon if you'd rather write it that way. And again, sometimes I keep them as fractions. You can do it the other ways. And then the next one, 32 kilometers over 4,000 meters. What can we reduce that to? When you want to simplify completely, I would use your calculator, especially if the numbers get larger. Nathan S.? You mean 125, not 225, right? Okay. 100, and then Nathan S., don't forget to have your units there. Okay. So pretty easy, same thing, but if they give you the ratio and say simplify, please make sure that you keep the units with it. Okay. All right, let's go to example 6. Okay, example 6 is a small, short word problem that we need to set up. So it says you host a party for 12 people. The food and drink for the party cost is a total of $66. We need to find the cost per person. So the word per, you know, is a unit rate or is a ratio because we're comparing the money to people, right? What should be the numerator of this ratio if we have to find the cost per person? Ben? Okay, that's the answer, but what goes in the numerator? Does money or people go in the numerator when we first set up our ratio? Okay, so money has to go in the top, so I want you guys to set up your ratio. Money goes in the top, and people are going to go in the denominator. Here's why. We need to find the cost per person. Anytime it says per person or per mile or per dollar, you need to get that number to be 1 or that unit to be 1. So we need to find how much it costs for every 1 person. The initial problem is $66 for 12 people. Does anyone have questions on how to set it up? Pretty easy. Okay, so we just need to simplify that. Ben told us the answer. You can simplify on your calculator if you want, or use long division, or use mental math. We end up with $5.50 per person for every 1 person for your party. So if you're charging people to come in the door, I would charge them that amount of money, then you're not losing or gaining money. Well, you could gain money, but that's kind of rude, right? You're having a party, but it's not? Okay. Okay. You shouldn't really make a profit on a party that you're having, though, right? All right, let's do one more problem. Okay, let's go to the closing, please, on page 4. This one's a little tricky, so I want to end class with this one. All right, this says, engineers designed a miniature robot. So this robot can crawl through pipes and vents that humans cannot access. Sounds kind of cool, huh? Oh, did you? Oh, neat. Okay. So it says the robot travels 1 inch in 3 seconds. So let's time out there. Let's write down 1 inch for every 3 seconds. Okay, so the robot travels 1 inch in 3 seconds. That is a ratio of something that we know about the miniature robot. It then goes on to say or ask us, how many feet does the robot travel in 4 minutes? We need to find how many feet the robot travels in 4 minutes. Now, my first question to you is, what do we have to change 4 minutes to before we go and solve this? What do we have to change 4 minutes to? Greta? Oh, try that again. Good. 240. Greta, explain your process of how you did that. Good job. So 240 seconds, that's just us converting 4 minutes to seconds. We are actually setting up a proportion right now. This leads into tomorrow's lesson really nicely. So what we're going to do tomorrow, before I move to the next part, is everyone understand why we did that? Everyone's okay? Okay, what goes in the numerator? Grace? Say that again. Okay, you're ahead of us. You solved it, and you're correct. 80 goes in there. But now, if we did not solve it yet, you would just put a variable there, right? Okay, so because that's our unknown, we need to find how many feet the robot will travel in 4 minutes. So now Grace told us, okay, the X is 80 inches. Does anyone know how Grace got that? Can anyone explain the process that she went through, Alexis? Awesome. All she did was take 240 divided by 3, which is 80, and then Alexis, what do you usually do with that number? Good job. So you would divide it and then multiply it by this number. We're going to talk a lot more about this on Monday. Now, we're not done. This is not our answer. Why is this not our answer? Drew? It's not the answer. I just said that, Ben. No, because we found X is 80 inches, but what does the question ask us? Okay, how many feet? So we need to convert this to feet. Okay, Nathan M., how did you get that? Okay, or what can we divide 80 by? 12. Okay, so if you divide 80 by 12, there's 12 inches in a foot. We can convert this to about 6.67 feet. So Nathan M. yelled out our answer here. Make sure you're rounding, I'd say, to the nearest tenth or hundredth. The question asked you to convert it to feet. Now, there are several ways you could have done this problem. Maybe you did not want to convert these to seconds. Maybe you wanted to use your proportion and just use mental math to get to this. That is fine. Nathan S.? Yes, we're going to do that on Monday. Yes. Ben? Yeah, that's why I rounded the 6 to a 7. But you can also do 6.6 and put the bar over it, or you can round it. I'm not going to get picky with that, okay? Yep, you can write 6 and you can change it to a mixed number and do 6 2/3. Drew? What'd you do? Ray? Okay, I'm listening, sorry. Wait, so you converted 3 seconds to be... Okay, that's just a little bit more complicated, or longer, but you can do it that way. Yeah, I didn't even think about that way. Yeah, that works. Anyone else, questions or comments? Okay, I need you guys and girls to open up your homework packet to 6.1. Okay. Yeah, you're not going to have a lot of it, so just give me a second here. I know it's Friday. Okay, I want you guys and girls to do numbers 1 through 9. (12) through, hey guys, all I said was guys. 12 through 17, 18, actually 12 through 20 is what I meant to say. And then 25. Okay, 1 through 9, 12 through 20, and then 25. Let me explain a couple things so you're not confused. Okay, 1 through 9, so it says here, bless you, tell whether the ratio is in simplest form. If not, write it in simplest form, and then write the ratio 2 other ways. So for number 1, I would simplify it first, and then write it 2 other ways. If it's already in simplest form, just write the word yes, and write it 2 other ways. No, you write 2 other ways. Okay, did you hear? So listen, ready? So for number 1, simplify it first. So you would change it to 229, and then write it 2 other ways. So simplify it first the way they give it to you, okay, and then write it 2 other ways. Number 3, just so you guys understand what I'm saying, you would write down yes, because it's already simplified, and then write it 2 other ways. Peyton? I'll talk about number 3. Do you know what I mean? Number 3 is already simplified. Yeah, number 1 we went through. Number 1 changes to 2 ninths. Okay, but 3 is already simplified, so write yes, and then you'd write it 2 other ways. 12 through 17, find the unit rate. What should your denominator have for numbers 12 through 17? Amberly? Good. For 12 through 17, your denominator should have a 1. You're comparing 2 quantities, but you want it to be the unit rate. So that denominator should have a 1. Are you guys all listening to that? 12 through 17's denominator should be a 1. Nathan S.? Okay, but you have to compare 2 quantities. So 3 to what? There you go. Okay? So always make sure you have 2 numbers, even if it's a 1. You're welcome, Ray. Everything else is pretty self-explanatory. Be careful when you get to number 25, the word problem. It's kind of like the miniature robot problem that we did as the closing. Monday and Tuesday, we'll talk about proportions in regards to solving them and setting them up as word problems. Okay? Tests will be in the grade book by the end of the day, and I will definitely give them back Monday. Okay? Any questions? Okay, when you're ready, go ahead and get packed up. Calculators need to go back. Girls are first today? No? Yes? Is it, guys?